Hello everyone and welcome back to our fourth section of our two-dimensional geometry unit. Today we are covering effects of changing dimension. So we have this first box that says explore. It says suppose we have the shape to the right, find its area. Okay, we can do that. We've done that before. We have a triangle here. We have area of the triangle is equal to 1/2 times the base, which is labeled as 12, times the height, which is labeled as 5. So I have 1/2 times 12 times 5. Well, I know half of 12 is 6, and 6 times 5 is 30. So that means that the area of my shape is equal to 30. Looking at my units, I have inches, so I have 30 inches squared. All right. Now it says, what if we changed the height or the base of the shape? How do you think that would change the area? So if you're thinking about that we're changing height or base, those are the dimensions. You can either change just the height, just the base, or you could change both of them. And because we're using multiplication in our formulas, that means that our area is going to have to be changed by multiplication as well. So whether that grows the shape or shrinks the shape is going to depend on what you're multiplying by. All right, so number 1 says could quadruple the height of the triangle from above. Now calculate the shape's area. What happened? Okay, so let's start by quadrupling the height. So if we're quadrupling, that means that we're multiplying something by 4. So I have my height is equal to 5, and what I'm really doing is I'm saying 4 times the height is going to give me my new height. So 4 times the height is equal to 4 times 5, which is equal to 20. So my new height of the triangle is 20. So now I'm going to take that and I have area is equal to 1/2 times my base, which is 12. And remember, we just were quadrupling. So technically what's happening here is I have 4 times the height right in the formula, but we already simplified that to 20. All right, by the commutative property, I can switch around the multiplication. Half of 20 is equal to 10, so I really have 12 times 10. 12 times 10 is equal to 120. So now my new area is 120 inches squared. We'll put that there for new area. New area equals 120 inches squared. What happened? Well, we multiplied one side by 4. And if you look at this, 30 times 4 is equal to 120. So what happened is the area also quadrupled. Let's write that down. The area quadrupled. And that's important. We want to remember that. Okay. So we changed one side. We changed just the height. And the change that we made to the height is the same change that we made to the area. All right, so let's try what happens when you do two sides. So it says, now quadruple the height and the base. Find the shape's area. How does it relate to the original area? Okay, so our quadrupled height we have above. That was 4 times h, which we have is equal to 20. And the quadrupled base, we have to find that still. So my base was 12. So I have 4 times the base is equal to 4 times 12. 4 times 12 is equal to 48. All right, so now if I put those in my formula, I have area, my new area, is equal to 1/2 times my base, which is now 4 times 12, which we simplify to 48, times 4 times the height, which we simplify to 20, And I'm going to do that same trick again where I have 20 divided by 2 is equal to 10. So I now have 48 times 10. So my new area is equal to 480 inches squared. All right, so 480. How does this relate to the original area? This might be one that trips you up a little bit. 48 divided by 30. So or 480 divided by 30 from our original area is equal to 16. So there isn't a direct number where we're changing things, but what you have to recognize is what we did is we did 4 times something and 4 times something. So you're taking those two 4s that we used to quadruple the height and the base, and you're multiplying them together. So the area is larger by 16. It is 16 times larger. Let's write that down. Area is 16 times larger, or times the original size. All right. Question 3 says, how is this reflected in the formula? Well, let's go back to the when we just changed one side and talk about how that changed things first. So when I just changed one side, in the formula, what I was really doing is saying area is equal to 1/2 times the base times my quadrupled height, which was 4 times the height. When you are multiplying, we have the commutative property, which says that you can multiply things in any order, which means that I can take that 4 and put it out front, and now I have 4 times 1/2 times the base times the height. My area of a triangle formula is 1/2 times the base times the height. So what I really have here is that my new area is equal to 4 times the original area. That's what my formula says. So when you're just changing one side, the area changes by the exact same amount. All right, now let's try with our shape where we changed two sides. When you change both the base and the height, in your formula, what you're really doing is area is equal to 1/2 times 4 times the base, because we quadrupled the base, and 4 times the height, because we quadrupled the height. Again, doing the commutative property, I can take those 4s and I'm going to put them out front. So I now have 4 times 4 times 1/2 times the base times the height. So what I have is 4 times 4 times the area, original area. So my new area is equal to the changes from each side multiplied together, multiplied by my area. So if we were to write that in a sentence or in general terms, for 2D shapes, these are non-circle 2D shapes, in general, I have if given one side, one changing side, the area changes by the same amount. So if you're changing one side, just the base or just the height, not both, the area changes by the same amount. 2. If given two changing sides, so you're changing both the base and the height in a situation like this, Then the changes are multiplied together, and their product is the amount the area changes. If you don't remember, the product means it's the answer to a multiplication problem. So their product is how much the area changes.
This covers what happens when you're working with most 2D shapes, but what happens when you're working with circles? Our second Explore box says,
does this hold true for circles? Well, the first thing we want to do is find the area of the circle. And we're going to leave our answer in terms of pi this time. So we have area for a circle is equal to pi times the radius squared. The radius of my shape is given to me as 4. So I have area is equal to pi times 4 squared, which means in terms of pi, my answer is area is equal to 16 because 4 squared is equal to 16 times pi. All right. Now we're going to go ahead and we're going to start by tripling the radius, and we're going to see what happens when we change the radius. So I have my radius times 3. So 3 times the radius. My radius was 4, so I really have 3 times 4, and that is equal to 12. So my new formula is area is equal to pi times my new radius of 12 squared, which is equal to 144 pi, because 12 squared is 144. All right. How is this reflected in the formula? In the formula, what's really happening is I'm saying that I have pi times altogether 3 times the radius squared. Notice that 3 with the radius is in the parentheses, all being squared. If you remember some properties of squaring, when you have multiplication in the parentheses and that's all being squared, you can square each thing separately and then multiply them together. So I have 3 squared is equal to 9, and I'm going to pull that 3 squared out. So I have 3 squared times pi times r squared. 3 squared is equal to 9. 9 times pi times r squared. Pi times r squared was the formula for the original area. So what I really have is 9 times the area. So what's happening here in general is if the radius is changing, you're multiplying it by something, you have to square the change because the radius is squared. So you're squaring the change and multiplying your answer by the original area. So if the radius is changing, square the change, then multiply the answer, or the square, by the original area. All right. So circles are a little different. You're squaring something and then multiplying. If you have two sides that are changing for non-circles, you multiply the changes together and then multiply it by the area. If you have one side that is changing, you just multiply the area by that same change.
Now that we've talked about the effects of changing dimensions, we're going to go ahead and do some examples.
All right, here we are on example number 1. It says the area of a rectangle is 50 square feet. If its base was doubled, what would its new area be? Okay, so first I'm going to take note of my important information here. I have area is 50 square feet. So area is equal to 50 square feet. Write that down. If its base was doubled. Okay, doubled means we're multiplying by 2. So I have base times 2. If you remember from before, we said that if you're changing one side, which is what we're doing, we're only changing the base, that change to the base is the same change that happens to the area. So to solve this problem, I have area of 50 times 2, and that will equal my new area. So I have 50 times 2 is equal to 100. So my new area equals 100 square feet. So what's happening is we have area is equal to base times height. And when you're doubling something, just one item, you have 2 times that item. So you really have 2 times the area formula. That's why we're just multiplying the change by the area. All right, let's go on to example number 2. Example 2 says if the base of a triangle was multiplied by 3/4, what would happen to its area? Okay, so we have that same thing again where we're just changing one side. Because we are just changing one side, what's happening here is we can take that change, which was the base by 3/4, and we do that same thing to the area. So the answer to this question is the area would be 3/4 the size of the original area. Example 3 says the radius of a circle is doubled. Radius is doubled. So I have 2 times the radius. What would happen to the area? Okay, if you remember from our Explore section in our example, we said that if you're changing the radius, you have to square the change and then multiply it by the area. So I have 2 squared, which is equal to 4, and that's what I multiply by the area. So I now say that I have, for my new area, the area or the new area will be 4 times the size of the original area. So this one will be 4 times larger. Again, let's go back to why this is happening. Let's look at the formula. I have from general area of a circle, pi times r squared. When you change the radius, so for my new area, I have pi times all under the square, my change, which is 2 times the radius. That's all being squared. Property of squares says that I can separate the multiplication and square them individually. So what I have is 2 squared times pi times r squared. That means what I'm working with is 2 squared, which is equal to 4, times the area formula. That's why I have to square before I multiply. Example number 4, it says one of the diagonals of a kite is quadrupled. What would happen to the area? Okay, so this is that situation where you have one diagonal that is being changed. So because you just have one diagonal changed, that same change is going to happen to the area. It says it's quadrupled. Let's just say the diagonal is p. So I have 4 times diagonal p. That means that my area has the same effect. So my new area will be 4 times the size. So the new area will be quadrupled. Or I could just say the area will be quadrupled. That's probably a more proper way to write it. So let's just go ahead and fix that. I'll just say the area will be quadrupled. All right. Example number 5 says the height and base of a triangle are tripled. What would happen to its original area? Okay, so before we were changing just one side, now we're changing 2 sides. So if you remember from what we said before, in general, if you're changing 2 sides, you have to multiply the changes together, and then that's what happens to the area. So because it says the height and base are tripled, what's happening here is I have 3 times the height and 3 times the base. So what I'm going to do is I'm going to take those changes and I would multiply them together. So I have 3 times 3 is equal to 9. So now that I have my total amount of changes, I'm going to multiply that by the original area. So that means that the new area will be 9 times the size of the original area. All right, there's our answer. If you're questioning why this is happening, we're going to take a look at what is going on with the formula. So the formula for the area of a triangle says I have 1/2 times base times height. When I am tripling the height and tripling the base, what's happening is I have my new area is equal to 1/2 times 3 times the base times 3 times the height. When I rearrange these things, it gives me 3 times 3 times 1/2 times the base times the height. That means that what I'm really working with is 3 times 3 times this section here is equal to the area formula. So I really have 9 times the area. 3 times 3 is equal to 9. That's what's happening here. All right, let's go on to example number 6. Example 6 says the height and base of a rectangle are multiplied by 1/2. What would happen to its original area? Okay, so I have height and base multiplied by 1/2. So I have 1/2 the height and 1/2 the base. That's 1/2 times 1/2 for our change. So I have, when you're multiplying fractions, you multiply straight across. So I have 1 times 1 on the top and 2 times 2 on the bottom, which is 4. So I have 1/4. So the original area is being changed by 1/4, by a factor of 1/4. So our new area, the new area will be 1/4 the the size of the original area. Notice when you're multiplying by a fraction, your area is shrinking. When you're multiplying by a whole number, your area is growing. Example 7 says a circle has an area of 100 square feet. So this time it's giving you that answer, area of 100 square feet. Let's write that down a second. Then it says if the diameter is tripled, what would its new area be? It says diameter times 3. Here's the deal. If your diameter is tripling, your radius is tripling too. So you're going to do the same process where you're going to square the change, which in this case 3 squared is equal to 9, and that is going to change the area. So my new area is equal to the previous area times 9, or 9 times the previous area, which in this case is 9 times 100, which is equal to 900. So the new area is equal to 900 feet squared. Example 8 says both diagonals of a rhombus are quadrupled. What would happen to its area? So I have both times 4. So my first diagonal, we'll call it P, 4 times diagonal P, and 4 times diagonal Q. Because we're changing both diagonals, I have to multiply the changes together. So I have 4 times 4 is equal to 16, and that is what I'm going to multiply by the area. So I have 16 times the original area. So the area, if I'm going to write this in a complete sentence, we would say the area, or the new area, is 16 times larger than the original area.
This is where we're going to stop for today. We'll pick back up with our next unit covering geometric probability.